Hey, so I just wanted to take a few minutes to go over number 6 from the homework. I think it was a tricky one that people were getting frustrated by, so I just wanted to take a minute to go over it. So this one was looking at an experiment, and we were trying to estimate the average amount of time it takes the rats to go through a maze or find food by going through the maze. We know that we're going to be constructing a confidence interval here. It asks for a confidence interval for mean. We have two different confidence intervals for mean. One that has the z, right? And that's the one that we use when we know what the population standard deviation sigma is. And then we have this other one that has the t critical value, and that's the one we use when sigma, the population standard deviation, isn't known. And that's what's going on here. There's no information here about the population standard deviation. So we know that we have to use the sample standard deviation instead. So we know we're going to be kind of working with this formula here, x bar plus or minus t alpha over 2 n minus 1. You're not going to be able to see this. Let me just move it over. There we go. Times s over the square root of n. So this is a number plus or minus that t alpha over 2 n minus 1 is just a number, s is just a number, and n is a number. But we're going to have to find that from raw data, okay? And it's going to be slightly different in R as well as on the calculator. So I'm going to do it on both just so that you can see the answer both ways. So if I click on this, it will allow me to see the data, I hope. Okay, I know this might be pretty small on your screen, but essentially you can go through and copy this. So if you just press this button and say copy to clipboard, and I'm just going to highlight it so I just get the numbers here. So I am going to copy and paste the data, Control C, and I am going to put it into R. Let me just open up R here. Should have had it open already. And so the first thing I'm going to do is enter in this data. So to remember to enter in data, you do X and then little arrow, so less than sign and then a hyphen, C, and then open the brackets. And then we have to enter in all the numbers separated by commas. In this case, when I copy and paste this, it doesn't have the commas, so I better go through and add them in. Comma, 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 comma. Okay, but the fact that they're on different lines shouldn't make a difference. You could put them all in one line. But if I press enter there, it should enter all these data in, and we can see it over here. There's an X value. There's 21 different numbers, and we could see a list of them if we needed to. Okay. So from there, let's go back to our formula here, right? So we need to get the sample mean. We need to get the sample standard deviation, we need to get n, and then we need to get this critical value. So let's start with x bar and s and n, because those are things that we can get directly from x here. So mean x, that's our x bar, so 52.5. In my case, your data set will be slightly different. The standard deviation of x is 13.9921. And if you need to know n, in this case, you can sort of see it from up here that it's 21, or you can count how many numbers are in the list. But in R, you can ask it for the length. Oops, not that thing. You can ask it for the length, okay? And it will spit out 21 to tell you that there's 21 numbers in the list. So you can use all of those numbers. And again, try not to round them so that we don't get any sort of rounding error. But let's talk for a second just about this t alpha over 2, because that can be a tricky point for some students. So they've asked us here, let's just double check. They've asked us for a 90% confidence interval. That was what they asked for here. So that means that 1 minus alpha is 90%. So if I draw my t distribution here, and I'll just quickly figure out the degrees of freedom is always n minus 1. In this case, n was 21. We worked that out. That's how many numbers were in that list. So in this case, our degrees of freedom are 20. This is the t distribution with 20 degrees of freedom. The confidence we sort of put in the middle. So 1 minus alpha is 0.9 is the area in the middle. And we have to take the sort of remaining error, the error, and put it in the two tails. So that is why, let me do this here. So if 1 minus alpha is 0.9, alpha is 0.1, that's how much area has to be in the two tails. And that's why I'm dividing it by 2, is to work out how much is in each tail. So 0.1 divided by 2 gives me 0.05. So this tail here is an alpha over 2, which has 0.05, and this tail here has an alpha over 2, which is 0.05. This here is my critical value, okay, that we're trying to figure out. This value here is t of 0.0520, comma 20, okay? And we can get that using, in R, it's QT, so Q because we want a quantile or a specific value that falls on the T distribution, and T because this is a T distribution. QT always wants to give it the area to the left, so it actually wants, let me highlight it maybe, it wants this area sort of in here, okay? So a couple of different ways to get that. I usually just do 1 minus the area to the right, so 1 minus the 0.05. But you could also see that you could take and add together the 0.9 plus the 0.05. That would also give you the area to the left. So I'm just going to write in 1 minus 0.05, which would be 0.95 if I worked it out. And then we have to tell it the degrees of freedom. So if I take and plug that into R, pull my R back up here. So I'd have QT 1 minus 0.05, comma 20, and press enter. So there's my critical value, 1.724718. I know that's probably pretty small. Maybe I'll zoom in so you can see it better. Okay. So you could take all of those things and blindly plug and chug into this equation here. And again, just make sure that you're not rounding until the very end. I personally like to do it all in sort of one calculation here in R because I can do that. So to get the lower bound, I do mean of X minus my critical value, which is QT of 1 minus 0.05, comma 20, which is my degrees of freedom, times my standard deviation, so SD of X, divided by the square root of n. So in the n in this case is 21. So I can just plug that in. So there, that gives me the lower bound. So it's telling me that it's 47.23. It asked me in this question to round to 2 decimal places. So I would only take the 47.23 and just note the rounding rules here. This 3 here is less than 5. So I really am just going to put in 47.23. Okay. For my upper bound, in R, you can actually press the up arrow and it will display your previous command. So I can take the previous command and just change this plus sign or a minus sign to a plus sign to get my upper bound. And so again, to 2 decimal places. So 57.76, except that the third point here is a 6, which means we need to round up. So this is actually going to be 57.77. This always makes me so anxious, but I'm feeling good. Nice work. So again, as long as you've got all those pieces right and you're keeping all of your decimal places, that should work fine. For those of you that are going to do things on the calculator, I will do that in a separate video.